Assalamualaikum warahmatullahi wabarakatuh. So we here gonna present our final presentation about our project-based learning robot line follower. Me from Team 5, Natasyahratu Zulharni, also my friend Syahputra and Nia Febrianty, gonna start our presentation. So let's start it from the table of content. These are our table of content, the content that we have to present today. So, and this is our result design, our final design of the robot line follower that we made for like 4.5 months. Then for the problem statement, we have body design selection and the gripper design selection. The problem is we have so many concept design, but we have to choose one as a final design after all of the discussion. And then for the component selection, we have to like considering about the remaining item that available on the Braille store, and then we have to set in the body and gripper size because there is a limit size in the requirement of the robot line follower. And the program is not running. Sometimes the program is had a mistaken from in the declare or in the pin setup or in the another void, but we have to fix it until the program is running and the robot is running. And the wiring robot doesn't match. Sometimes the wiring robot is there is a mistake of the wiring, so the robot cannot run the program. And there is a time when the wiring of the Arduino Nano connect into the pin 5 voltage of the motor driver, so the Arduino Nano cannot move because it has range of voltage for running is 5.5. So the Arduino Nano need more voltage than 5.5 voltage. So the pin, to fix it, my team connect the wiring from Arduino Nano to the 12 voltage pin. So the voltage is enough to running the program in Arduino Nano. And then the line sensor placement is too low. For the line sensor placing, it's have to considering about the gap, so the placement of the line sensor have to be correct for the heightness, and our line sensor is too low, so it cannot detect the line pad correctly. So we have to adjust this into a 1 centimeter or more higher than before. And then for the project timeline, in September we focus on start making a 3D design, and then in October we choose the final design and make a robot prototype, also take a midterm presentation. And in November we start doing mechanical, start programming, and then doing electrical. In December we doing a robot trial to the line pad, and then if there is any mistaken we have to correct it, and we have to preparing for another report of our project demonstration. For the system requirement review, our robot is already can follow the line pad, but the robot also already can take the obstacles, but it's not that good. It can, but it's not that good. For the hardware we use is the microcontroller Arduino Nano, and we're using line sensor, and our base chassis of our robot is base acrylic, and we using 2 motor DC And for the program, we use Arduino IDE. For the robot size, I can confirm that our robot size is under the requirement because we already fixed the degree of our servo, so it cannot be more than 15 centimeters before demonstration. For the project timeline, we have 4 months to finish this project, and from the weight, I also can confirm that our robot is under 3 kilograms, and for the battery, the maximum capacity is 12 voltage, but we use the NCR battery, so the voltage is have to under the 12 volt. For the budget, the limit budget is 400,000, but we already use like 377,000 for now. And for the wiring and electrical, we have to connect the Arduino to the battery because the Arduino cannot running the program if there's no power supply to run the Arduino Nano. So, and then the line sensor connect the ground, and the VCC of the line sensor connect into the Arduino Nano, and then for the sensor 1 and until sensor 5 pin, it's connect into a digital pin in Arduino Nano. And then for the motor driver, the input pin in motor driver, it can be connected into a pulse width modulation pin in Arduino Nano, so we can adjust the speed and the rotation of the motor driver data. And also for the servo, we connect it into a pulse width modulation pin 2, and then for the motor DC, we connect it into the pin output of the motor driver.
This is the initial design created using CAD concept. At this stage, our focus was on building a basic model of the component to understand the overall structure and dimension before proceeding with assembly. After completion the initial design, we move on the critical design stage. At this stage, we added detail such as component positioning, mechanical system, and ensure the design could be assembly efficiency. The design was evolved to ensure technical feasibility. Next, we create a draft design tailored to the needs of the prototype. To test mechanical function directly, we used cardboard as the primary material for building the prototype. Cardboard was chosen because it is easily accessibility and efficient for initial simulation. After undergoing the revision process and prototype testing, the final design was refined in CAD concept. The design has been adjusted based on prototype testing result and is ready for future implementation. This image shows the final optimized design.
Okay guys, this is the list of our component. It is the Arduino Nano, micro servo, sensor garis, motor DC, freewheel, battery NCR, and 20 wheel, battery holder, bracket motor DC, nylon spacer M3, spacer chopper 20 mm, and motor driver. Next, this is a tin. and this is nut M2, push button, small glue, cable teeth, acrylic, cable male to female, and cable male to male. Next, so this is bill of the materials our robot. So this is a budget for all the components we buy. This is so many, and this is a loss on purchasing components, our components. So this is, I think this is so many budget. And so next, so this is the our flowchart program. So in the conditional, the gripper on 60 degrees and the arm 55 degrees and the robot stop. So what if sensor 1 until 5 all detect? If the only sensor 3 detect, the robot is move forward, and the only sensor 4 detect, the robot turn right, and the robot only detect sensor 2, the robot turn left. So if the robot didn't detect the sensor, the robot stop. So what if the sensor 1 until 5 all detect? So this is action 1. The robot stop motors and move forward. So in the action 2, the robot turn left. The action 3, the robot stop motors and the arm on 10 degrees and the gripper 0 degrees, and the arm 60 degrees and the robot turn left. In the action 4, the robot stop and the arm on 10 degrees and gripper 70 degrees and the arm 60 degrees and the robot turn right. So in the action 5, the robot stop and the gripper 70 degrees and the robot move forward. So in the action 6, the robot stops. Okay, thank you.
Yeah, yeah. Bobby Valentino.